Hello my friends, and welcome to this session about Intro to Serverless SQL in Azure Synapse. My name is Brian. Let's get started. I'm really excited to be able to present this topic of giving everyone here an introduction to the Serverless SQL endpoint in Azure Synapse. Thank you for joining, and let's get to it. The agenda for today. But first of all, while I'm presenting this session to you, and as with the other sessions in this conference, I'm also be chatting with you live. So don't hesitate to ask me a question or write a comment. First of all, we're going to see an overview of the Serverless SQL pool, how it is built from Microsoft, the cost, usage scenarios, and the code to use to access the server. Then I'll show you how to start the Synapse Analytics workspace, spin everything up, and get things rolling in Azure. To help everyone who has not yet been familiar to the Synapse Studio experience, I'll also guide you on an overall basis through the different UI settings in the portal. Then the fun stuff, the code and how to read data from different types of data sources. I've brought demos on CSV files, Parquet files, and JSON files. The part of accessing Cosmos DB and Dataverse is not covered in this introduction session. I'll also show you some tips and tricks on how to get the most out of your setup. Lastly, I'll show you how to get started yourself. The scripts and demo data will be provided from the conference to all attendees. Who am I? Well, my name is Brian. I'm the principal architect of Fellowmine Denmark. I'm certified Microsoft trainer, and I've been that for 4 years now. And this year I was assigned a fast-track recognized solution architect on Power BI. And if you want to hook up, do it on LinkedIn or GitHub. You can find the description here below on this slide. So, on to the Serverless SQL pool. The Serverless SQL pool is a part of every Synapse Analytics workspace. That means you cannot delete it, you cannot do stuff about it. It is just there out of the box when you provision the service and is ready to use. It's a pay-per-use setup, approximately $5 per terabyte of processed data, with a minimum of 10 megabytes. So if you query data and it's only 6 megabytes, you'll be charged for 10 megabytes of data. To this, you'll need to add the read and possible data movement from your blob storage. The data movement will come to play if you're reading from different region than the Synapse workspace is provided at. So if your workspace is in Europe, but you're reading data from the US, you're going to pay some data transfer between those regions. The service leverages the ability to read data from CSV, JSON, and Parquet files from Azure Data Lake, reading data from Cosmos DB, and reading data from the Dataverse service. As mentioned before, the two last items are not covered in this session, as mentioned earlier. The really cool thing is that you can use standard SQL syntax with a few limitations. I'll cover that later. And the approach does not need to move or copy the data to use the T-SQL language. The architecture. At the right-hand side, we have an application or user who is accessing the SQL Serverless pool. The SQL Serverless pool and the access point is actually, from Microsoft, called a control node. The control node is a single point of entry and the brain of the Synapse SQL. This is also the case for dedicated pool, which is not in this session. It is the front end that interacts with all applications and connections. In Synapse SQL, the distributed query engine runs the control node to optimize and coordinate parallel queries. So this engine is also dismantling your query and trying to figure out how can I best parallelize my data query in order to get the most performance out of my Serverless SQL. In Serverless SQL pool, the distributed query processing engine runs a control node to optimize and coordinate distributed execution of user query by splitting it into smaller queries that will be executed on compute nodes. It also assigns sets of files to be processed by each node. The compute node provides the computational power here. In Serverless SQL, each compute node is assigned a task and a set of files to execute a task on. Task is distributed. Every task is a distributed query execution unit, which is actually a part of a query user submitted. Automatic scaling is in effect to make sure enough compute nodes are utilized to execute user query. A small caveat here is that it does not always just utilize all the compute node that it has. It only utilizes the compute node that you actually need in order to read the data efficiently enough. Not fast enough, but efficiently enough. The compute nodes store all user data in Azure storage and run the parallel queries. The data movement service, I'll have to click there to change it. The data movement service is a system-level internal service that moves data across the nodes as necessary to run queries in parallel and return accurate results. If we parallelize this to a on-premise SQL server or just a SQL server in Azure, this is the gather streams you'll see in the execution plan, where it waits for every parallel process to gather the data and return the results to the end user. So why use Serverless SQL in Azure Synapse? Well, the benefits are, for once, you have data discovery and exploration. You can quickly reason about the data in various formats, those Parquet, CSV, and JSON, in your data lake, and you can plan how to extract insights from it. You can also build a logical data warehouse, provide a relational abstraction on top of raw or disparate data files without relocating or transforming data, allowing always up-to-date view of your data. So when the files are stored in the data lake, it is not moved, it is not changed on this logical data warehouse. The SQL endpoint just exposes the data in a SQL-like manner, like a view that you can do select statements from. So when a file is updated in the data lake with an instance, then the data will be updated in the view. Last but not least, you can do simple data transformations, a simple, scalable, and performant way to transform data into data lake using TSQL language. So it can be fed to BI and other tools, or loaded into a relational data source like Synapse SQL databases, Azure SQL database, etc. Other benefits are that data engineers can explore the lake, transform and prepare data using these services, and simplify their data transformation pipelines. Data scientists can quickly reason about the contents and structure of the data in the lake, thanks to features such as open row set and automatic schema inference. I'll come back to that later when we're in the demo. So, data analysts can explore data and, if you like, using Spark external tables created by data scientists or data engineers using the T-SQL language or their favorite tool, which can connect directly to the Serverless SQL pool, which I will show you later, just a SQL server endpoint. BI professionals can quickly create Power BI reports on top of data in the lake and on these former mentioned Spark tables. So, the T-SQL support. The T-SQL support is almost the same as in a normal SQL database, but the DDL, so the data definition language, does not support tables, materialized views, and functions. This also makes sense for me, at least, because the Serverless SQL pool does not have an attached SQL storage to store data on. It fully relies on the underlying and attached data lake storage. It is though possible to create an external table called a CTAS, create external table as. This will store the data in the data lake as Parquet files and read the data from these files. I'll show you that in a minute. Around security, security support, what it needed to support. the best thing from my perspective is the object level support, which means that each object can be granted or denied access to a specific user or group. Just like a normal T-SQL database, even though the physical storage is on a data lake, the serverless SQL endpoint does a good job supporting security on needed levels. And of course with Azure and Azure Active Directory integration fully. The select statements almost support the full select feature from SQL Server. A minor subset of features are not yet available, and for those could be recursive CTEs, which are not yet supported from the serverless SQL point, but perhaps it will be implemented later. So, let's create a Synapse workspace. For the sake of this demo, I've already created a resource group called Data Platform Summit. And right now it's empty, so I'm going to create a resource. Here you can just search for resources. I'll type in Synapse, and then it shows me Synapse Analytics. Top left. Here you can see all introduction to the service. I'll click Create. And then you need to type in a resource group name. This resource group name is the name of the extra resource group that the service will create for you. And as you see, it has some demands on how the naming should be. And I also need to create a workspace name for this. This also has some demands in the naming convention. You can see the help to the right of the field. And here I'm choosing the region. I'm choosing Western Europe. I'm in Denmark, so the Western Europe is closest to me right now. Here I need to create a storage account, and the storage account needs an account name. This also has some limitations to the naming. So here I'm just calling it Data Platform Summit. And the file system name, I also need a file system for the Azure Synapse to work. This also needs some naming conventions. I'm just suffixing with fs. It does not accept underscores. And then I'm ensuring that I assign myself as the storage blob contributor. Here I'm choosing how to authenticate towards the SQL endpoint. I'm choosing both a local user, like a SQL user. It defaults to SQL admin user, and I need to type in a password. It is somewhat strict with the password. And of course, the confirmed password needs to be the same, if I can type. Bear with me here. So, there you go. Then without further ado, I'm just here clicking next. I won't encourage you to enable the managed virtual network, because then the service will be closed down to a network, to a VM. And now it shows me what it is going to start, and now it is actually, I'm clicking create, and then it's submitting the request to Azure, and starts to spin up the services. And this shows the process of the deployment process. And while this is running, I'll try to illustrate to you what it is actually doing right now. So here's a drawing what's happening inside Azure right now. So right now Azure is spinning up a blob storage. It is also spinning up a SQL. Let me just right now, for the sake of it, call it a SQL endpoint, because it is not a SQL server as you know it. It is making sure that these two are connected so that the SQL server can read from the blob storage. All of this combined is what I, in my daily use, call Synapse. Bear with me for my writing here, because I'm writing on a screen. So let's go back to the Azure portal and see how things are doing. So now the services are almost done. I just need another green light here. I have, there you go. Now all services are provisioned. I have now all 6 services provisioned. I have the Synapse workspace, I have the file service, and I have the storage account. So now everything is set up, and the initial setup is like this. I have the Azure Synapse Analytics as an umbrella above the Azure Blob Storage and the Serverless SQL endpoint, and the two are now connected directly in the Azure Synapse Analytics portal. Next up is a quick walkthrough of the Synapse workspace, what it looks like, what the UI is, and how I'm using it. So let's dive into the Synapse workspace. I'm just going directly to the resource group. Here it shows me I have the storage account, Data Platform Summit, and I have the Synapse workspace with the same name. If I then click to Data Platform Summit, I'll be guided to a new place. Here I can see all the metadata from the service. I can see the resource group, and to the right you can see the Serverless SQL endpoint. It's called Data Platform Summit -on-demand SQL.azuresynapse.net. If I need this, so I just click the copied sign. Then I'm going to open Azure Synapse Studio. This is the main place where you're going to work within Synapse. It just takes a second to start. And here you have the first view of the Azure Synapse portal. It gives me the name, Data Platform Summit. I get a quick drop down of what is happening. I can create new stuff, but I won't do that because I need to show you the things that are doing here. The home button, the data button is, the home button was where we were. The data button is showing me the data that I've hooked up to the Azure Synapse portal. By default, I'm getting a linked service to the blob storage that was provisioned while turning on the service. Right now it is empty. In the development pane, I have nothing now, but I can then create a SQL script, a notebook, a data flow, Apache Spark, job definition, and so forth. I'll come back to this later. In the integrate, I can create a pipeline. I can do a link connection and all stuff. There's also galleries where I can choose a quick start. In the monitor, I can monitor my request and my SQL pools, what is happening. I'll come back to this later. Right now it is empty because nothing has been done yet. And in the manage part, this is all management. I can manage my SQL pools. I can see what is the cost of it. I can cost control it. I can see my triggers if I have any. I can do my access control here. Who has access to what? This is me. I have access. I'm the system. I'm the Synapse administrator. I can see the credentials. This is a managed identity. I can also do a Git integration directly to a Git repository. I can do that right here. That was the workspace. Now I'm going to dive in directly into the fun stuff, the query of the data within the Azure Synapse workspace. As mentioned before, directly from the default settings, I can query CSV files, Parquet files, and JSON files. The CSV part support all formats of CSV. Some formats that have special configuration, like pipe as the limiter, some text qualifiers, and special line ends, new lines, need special configuration in the SQL language, but they can all be queried from within the Synapse workspace. The Parquet files, the compressed file format with built-in column store index, is also directly applicable and can be used without further configuration. The JSON files is the same pane if you wish as in the normal SQL. It is supported with the OpenJSON syntax, and you still need to define your cross apply and auto apply to get things to work for you. So let's dive into Azure Synapse and look how it's done. As with any other demo, I have cheated a bit and loaded data directly to the to the storage account. I've loaded 3 files. I've loaded the New York taxi trips data both as a Parquet file and as a CSV file. And I have also loaded a demo data file from my own website in JSON format in order to show you all the 3 formats that you can do directly in SQL Serverless. So here I'm right-clicking the Parquet file and just a select top 100. It gives me an auto-generated code. I can change the name of the SQL script at the top to my right. And as you see, it instantly changes the name to Taxi Parquet. I can run the query and I can get my results. Rather quickly, I can start to explore my data. Let me give ourselves some workspace here. I can see all my data in a classic grid format. I'm only getting top 100. In the top, I can also select to get a chart, a visual representation of this data. I can select my category column. Let me see if I can get something out of this that makes sense. I'm selecting the taxi count. Then I need to remove all the other stuff. You see something is starting to emerge. So now I have my fare amount. How much did this fare cost, along with the trips distance in a line chart. I can use the line chart as I wish. I can hover the data. I can go back to my table. I can also change the chart to a area chart, a bar chart, column chart, a pie chart, and a scatter plot. But let's go back to line and back to the table. And from this, I can now start to do standard T-SQL stuff within this Parquet file. Let's try the same thing with the JSON. Again, select top 100. Here I'm getting a standard script for JSON file. I'm just renaming this also to taxi.json. I can run this. And here you need to know that a JSON file in Synapse Analytics, even though it is auto-generated some T-SQL syntax for me, I need to be aware that the result set returned to me is in one column, and I need to do the formatting myself. And for the sake of this demo, I'm going to fast forward here so you don't see all the T-SQL writing. So now I've written the code and it is executing, and while we're waiting for the result set, I can show you that the field quote, the field terminator, and the row terminator has special characters because the format in a JSON file is still CSV, and that's just the way it passes it. And as you saw in the code, you still need to do the cross apply in your JSON file. And the table result set is just as you would expect any other JSON file in a SQL server. I can still manipulate this as a chart. The last file, the CSV file. Here it also auto-generates a script for me with the parser version 2.0. I'll come back to the parser version later in this session on what is it and what's the differences, because Microsoft is doing some rather nice stuff with the parser version. And directly from the standard script, I can get my data out. I can see my columns. If I need to remove the top columns, as you saw before, I need to rewrite the query, and I'm going to fast forward to save time and to show you how this works. So now I have rewritten the query to do a with statement within the auto-generated code, and then now I can manipulate the query to fit my needs. I've also added the first row equals 2, because then I'm selecting the first row in the set is always row 2, and then I'm specifically defining my headers with data types. I've also changed the name of the script file to suit taxi.csv. Please notice that the file types I have used are only invarchar and decimal, because when I'm using the parser version 2.0, I'm enforced to have a specific format if I'm going to use integers or date times. So in this specific example, I need to specify this as either decimals or invarchar because my format is not suiting. Now we have seen how to query the data on the three formats, but what do I do with my scripts, and can I create my own database to work with all this? Yes, you can. You can also create a schema. Let me show you how. So back to the Synapse workspace, back to the development tab, click on a new SQL script, and here I'm getting the standard IntelliSense from the SQL Server Management Studio that you know. I can create a database. This database I'm calling Taxi Demo, and I'm choosing a specific collation because I know my text file is a UTF-8 file. I'll come back to this later. So if I then refresh my database options here, it just takes a second. There, then I can now use my new database called Taxi Demo. In this database, I would like to create a schema called Taxi. If I can type, I run that, and then the schema is now created within my database. I'm changing the name of the script just to be named setup, because then I can save it later. Then I can go back to my original scripts, alter it to create or alter view taxi.parquet as, because this is my parquet file. I need to choose the right database. There you go. And I can do the same thing for my JSON scripts and my CSV scripts. So taxi.json as, and the creator also view statement is just if the view is already existing, it's just altering it instead of creating it. And the last, my taxi.my CSV file. So now I have all my scripts. They are deployed to my, I need to choose the right database. They are deployed to my database. And but what happens if I have a correction error somewhere? Yeah, there you go. Now I've created all my views. So how do I then access them from my application? Well, let me show you. Let me just copy the address to the serverless endpoint. You find it in the metadata in your Azure portal. Here I'm in Azure Data Studio. I create a new connection. Then I need to paste in the server name. The authentication is, I need to authenticate myself. It is just a matter of logging in with your AD account. So now I'm authenticated, and I can just click OK, and then it opens up my new on-demand SQL server. Here I can see my databases, my taxi demo, and I can see my views. All my views are here. I can right-click and do a select top 1000, and I'm presented with the data in an instance. It is much more quick to return the data through the application or the user accessing the serverless endpoint than through the Azure Synapse Studio. Azure Synapse Studio is only meant for development and code development and error corrections and so forth, and the actual usage of the views are just very, very snappy when using CSV, JSON and Parquet files. From here, I can do a view on a view, and then I can do another view. And then from this, I can actually build an entire virtual data warehouse based on SQL Server Serverless. As a demo, I can do a sum from the Parquet file. It is very, very snappy. This is almost 11 million rows. And of course, I can also do other stuff. I can do select, I can do group by, I can do select star. I can do whatever I wish to do in a normal T-SQL language with a few limitations, like the one I mentioned, the CTEs. With a recursive CTE, I cannot do that yet in the serverless endpoint. Perhaps it will be changed later. So now I have my database, I have my scripts set up, but how do I save this? Well, there is a button for that. I can press the publish all button. It shows what it is going to save to the Azure portal. And then once it has been published, it will show up as a notification on my top right corner. It just takes a second. There you go. Now the things has been published in my Azure Studio. So next time I open my Azure Studio, I can find my files. If I miss this, I'll get a pop-up when I close the window saying, oh, you have unsaved changes. Do you wish to publish them? Yes, I do. If you don't publish it, it will be lost forever, and you need to redo the scripts from the portal. Another thing that I promised to show you is all the SQL requests. Because we now have done a lot of SQL requests, we can find these. I also promised to show you how I can follow up on my SQL usage and my SQL requests. Right here in the Monitor tab, within the SQL request, I can follow up on whatever I have done within the SQL Server. I can see what amount of data has been used, whether or not they are failed, who has run them, what has been run, and I can actually do a rerun of each of the queries because I can see all the details behind the query. This is just an internal query. But if I click on the right one, there, then I can see I have my select statement that I just did a minute ago. And other things, I can see the date, I can see the user. All stuff, and directly from this I can maintain and monitor my entire SQL Server setup from the serverless endpoint. I can filter. Right now it's only a demo, so I cannot filter more than what I've just done, but I can apply filters and get my data that I need. So now we have defined our views in the Azure Synapse portal. We have defined our data structures within both the CSV, the Parquet, and the JSON files. And then what can I use all of this to? How can I leverage the usage scenarios within Azure Synapse to then create my data warehouse? Here comes in the CTAS, the create table as structure. It is a functionality within the Azure Synapse portal where you can read data from your coded views or directly from your files within the data lake, and then have Azure Synapse create a physical Parquet file back to the data lake with the calculated data. So if you then create views and then another view, and then you join the data and you do data modeling, and you want this data to be pre-calculated and ready for other usage within the SQL Server endpoint, then this is the way to go, to use a CTAS. It's short for create external table as this slide says, and the usage scenarios is, as I just mentioned, to pre-calculate a dataset that takes too long time in the serverless endpoint to be returned to the end user, then you can pre-calculate it, save it back to the Azure Data Lake, then create another view upon that Parquet file, or just use the external table as a source. I'll show you that in a minute. So this is the process that I'm talking about right here at the bottom. Here at the bottom, I'm reading my data from the Azure Data Lake. Perhaps I'm transforming it in the serverless SQL endpoint from the application or the end user, and then I'm saving it back to the Azure Data Lake as a Parquet file and actually manifesting this Parquet file as a table in the SQL Server endpoint. The usage scenarios here is, perhaps you already guessed it, is to create a virtual data warehouse. Based on what you have just seen in this session until now, is building up to actually give you the tools to build a virtual data warehouse based on the serverless endpoint and the Azure Data Lake storage. So, the virtual data warehouse, how many layers you want in your data warehouse, you can build a fully functional virtual data warehouse based on Azure Synapse with the views from the data lake and the CTAS. Here I have added 3 layers. It can be 2 layers, it can be 5, it can be whatever layers that you need. The data is read in each stage from the data lake. If you then need to store the data as a pre-calculated table, you can do that using the CTAS, save a Parquet file, use that external table as a source for the next layer in your data warehouse. Next, I'll jump back to the Azure portal and show you how you can do this. So now I'm back in my Azure portal. I've already predefined a script because this takes some time, so I did it to save time. The first thing you need to do is to create a master key to encrypt your database. This master key needs to be a strong password, so you need both numbers, special characters, and text. And if you don't fulfill the special needs, you'll just get an error when you create it. I already created this master key, so I'm not going to show you how it works, but it's just a matter of executing this line. The next thing you need to do to create an external table is to make sure that the credentials from the storage account is saved within the serverless SQL endpoint. Here, to do that, I'm creating a scoped credential named ADLS credential. The identity should always be a shared access signature, and this specific shared access signature I'm getting from my storage account within the Azure portal. Here within the Azure portal, I'm in my storage account called Data Platform Summit. I'm in the point in my left bar called Shared Access Signature, and then here in my middle bar, in the middle of the window, I can configure how my shared access signature should be. Right now, for the ease of use, I've just selected all tick marks. I've selected a date from where it starts and to where it ends. And then I need to click this button, Generate SAS and Connection String. Then I'm presented with these 6 text strings. The one I need is this SAS token. I need this text without the question mark. It's very important to not copy the question mark, but you need to copy the whole thing. When you have copied this, then you will see this is the same thing that is standing here. This is my secret. This is the secret token to access the data lake from my Synapse to create a table. The current security setup within Azure Synapse is to only read data. So in order to write my data back as a Parquet file, I need to create this scope credential. So here I'm creating the scope credential. It runs. After that, I also need to create an external data source. External data source is more or less just, you can look at it as a, where do I store my files if I'm not choosing anything? Well, here I'm storing it at my at my storage account, the Data Platform Summit. You can find this address if you click in your Azure Storage Explorer. Let me show you. I have it here. This is my Azure Storage Explorer. I'm at my blob container called Data Platform Summit file share. And down here, this one. This is the URL that I need to copy into this URL. This is the root folder. And then to access the external data source, which is also a data target, or in Azure called a sink, you need to to define the credential, which we just defined up here, and the credential is just what it is. If I run this, then the external data source is created within my serverless endpoint. Then I also need, the last thing is to create an external file format. In this case, a Parquet file format, because I would like to write my data as a Parquet file. The Parquet file format is just my name. The format type is Parquet. And then as a data compression, this is the default. Data compression is Hadoop called Snappy Codec. That's just the default compression type for a Parquet file in Azure Data Lake. So if I execute this, then I'm creating the external file format. It's just a matter of metadata. These three things is just a matter of creating metadata to be ready to create my CTAS. The next thing and the last thing is to create my actual external table. The syntax is create external table and then the name, first the schema and then the name. Here I'm just calling it CTAS. I can call it CTAS CSV because I'm exiting the CSV file with, and then the location is actually the folder to where I would like to save my Parquet file in my blob storage. So this is the folder. If the folder does not exist within your blob storage, then the serverless endpoint will just create the folder for you. The data source is the demo. This is the data source up here, the demo data source, and the file format is this file format that I just created. Then the as you would any other table. And then here I need to define my select statement. This can be the select statement from my views, or I could, if I would like, copy all of this, copy, and then paste it down here. And then I'm creating my external table to read directly from the defined select statement. But in this case, perhaps I've done a view that does some joins between tables and does some calculations and so forth. And the result sets from this view, I would like to create as an external table. So if I run this, it just takes a while. Right now it's reading the data out from this view. It is manipulating the data to be in a Parquet format. It's adding the constore index. It's sorting the data to match this index, and then it's saving the data directly to my blob storage. 11 seconds. If we go back to my blob storage here, and if I press refresh, I'll see that I now have a new folder called CTAS. In this folder, I have a Parquet file. This Parquet file is actually the data that I have just written. This is pre-recorded, so you will see that this is pre-recorded on the 12th of August, and I just created this file. But this file contains now my data and the constore index within the Parquet file. Now I have created an external table. This external table is also available through Azure Data Studio. If I just refresh the tables folder and I unfold, then I can see now I have an external table, in brackets external, called taxi.ctascsv. If I unfold this, I can see my columns. This is the same columns as I defined in my CSV file, and I can do a select top 1000. There you go. This is so much faster than accessing the files, the CSV files or the JSON files from the blob storage, because this is now a physical file that I read. It is prepared to the select statement that I need, and perhaps it has also added some business logic and some business value. Perhaps it has a join or more joins. Now back to my script, and just to show you that you can also do a select statement, because now I have my, if I then create a new table and perhaps I add data to this table, then it will create more data, more Parquet files. These Parquet files will be named in a name convention that you saw in the storage account here, with a name that I cannot guess. Well, Serverless has you there. It has your back, because you can do wildcards in your strings. This wildcard is now, so I have my path to my storage account. I have my folder, the cetas, and then I have a start.parquet. So just select all Parquet files. I'll just need to tell the engine that this is Parquet file, and I can do a select star from this Parquet file. And as I mentioned earlier in this session, the result set in Synapse Analytics Studio is slower than if you do it in your application or in Data Studio. So here I see the same data as I would from my external table. So I can still, from this external table, I can then perhaps do another view, or I can use my external table as I would any other table or object in my SQL Server. Here is some tips and tricks if you would like to try this yourself. If your CSV file is UTF-8 formatted, then I would suggest you to create a database with a UTF collation. This helps and removes a lot of frustration. And the parser version. If you're using the parser version 2, then it is much faster, but it demands a specific formatting in the CSV file. You can read more in the addendum slides, which will be provided from this session later. So you can do this all by yourself. All demo data and scripts will be provided. You need to change the address of the storage account to point to your own account if you are copying the scripts directly, or if you're just right-clicking the files in your own blob storage, then the address will be changed accordingly. Data is free to use and comes from the public data endpoint, the New York Taxi website, from the Parquet and CSV, and the JSON file is from my own blog. So if you would like to use that, then by all means just go ahead and use it. So this brings us to the end. This brings us to the end of the session. I'm still available in the chat, in the Q&A box, to answer more questions, or connect with me in the virtual network lounge. A special thanks to Microsoft and our supporting data platform geeks and SQL Server geeks, the community initiatives. Thank you for today. Thank you for attending. I hope you got something out of this. I know I did. I know I did. And feel free to ask me questions, and I hope to see you soon again. Bye.